Welcome back, guys. Welcome back. This is your mathematics and physical sciences tutor. So this is the second video that involves the polynomial functions that undergoes division. Okay. But this video is very unique from the previous one because from the previous one we had a quadratic function and a linear function, but in this case I have two quadratic functions. So let us try to see what we get if we divide f of x by g of x and g of x by f of x. Okay, fine. So we still going to use the long division method. Okay, so let me give the structure of that long division method in application. Yes, so remember the denominator, the function from the denominator, you have to put it outside, and then the function from the numerator, you put it inside. So the procedure is still the same. So your division focuses on what? On the terms that has the highest degree, right, from both of your functions. So in this case, this term has the highest degree, so we're going to focus on this term. And then from this function, this term has the highest degree, so we'll focus on this function. So if we divide x squared by x squared, so our resultant answer from the division of x squared by x squared is going to be 1. Okay, so we take this one, we multiply everything that is here. So 1 multiplied by x squared is x squared. 1 multiplied by a -1 is -1. Okay, then after multiplying, now we need to subtract this from that. Okay, so we subtract what we got from what we just divided from. Yeah, well, so now we're gonna take divide like terms. Okay, I mean subtract like terms. So this will subtract that, we're gonna have 0. This one, because it doesn't have like a like term here, it does, but remember it is invisible. Okay, so which means we're just gonna drop our 2x, and then 1 minus 1 is going to give us plus 2. Okay, but remember that we only divide a term that has a degree that is equivalent or greater than the degree of what? Of the term that we are dividing with. Remember, we are dividing with x squared, which means we are only going to divide a term that has a degree of 2 or anything greater than 2. So because of this has a degree of 1, we can't divide it. So this one is going to be our remainder. So this is what I've been talking about when I'm saying if you have a term that has a degree that is less than the degree that of the term that we are dividing with, then whatever that you got there is going to be your remainder. Okay, so which means your final answer, if you divide f of x with g of x, you will definitely get that one plus our remainder, which is 2x plus 2 divided by what we've been dividing with, the whole denominator function. So we're just gonna put what here? X squared minus 1. Okay, so this is your final answer. This is your final answer. So now let's check what we are going to get if we divide g of x with f of x. Okay, so our skeleton, so g of x is what? G of x goes inside because it's the numerator, x squared minus 1, and then f of x goes outside because it's the denominator, which is x squared plus 2x plus 1. The procedure is still the same. Remember, the procedure is still the same. We only focus on the terms that has the highest degree. So in this case, this has the highest degree, this has the highest degree. Okay, so we take the term of the highest degree from outside, then we divide the term of the highest degree here. So we're going to have x squared divided by x squared, it gives us 1. So this one will multiply everything here, which means we're going to have what? X squared plus 2x plus 1. Okay, then we take this, we subtract everything that is here. So the easiest way is to just take a term from here and subtract a like term from the bottom function. So x squared is like term with x squared, they cancel out because x squared minus x squared is 0. And then minus 1 is like term with this one. So minus 1 is going to give us minus 2. And then this one we just drop it. It doesn't have a like term from that. But remember, we taking this function and we subtracting this function. It's like x squared, okay, minus 1 minus the whole of x squared plus 2x plus 1. Okay, so which is equivalent to x squared minus 1 minus x squared minus 2x minus 1. So this is nothing but this cancels that, and then we're going to have negative 2x minus 2. Okay, which means here our resultant or our final answer, we're going to have minus 2x minus 2. And remember, our term with the highest degree from this is this one. Okay, so what is the degree? The degree is 1. But a term with the highest degree from here, from the function that we are using the term to devise, is 2. And then 2 is greater than 1. But then we cannot divide a function whose degree is less than the degree of, or let me say the term whose degree is less than the degree of that we are dividing with. So which means this will be our what do you call, our remainder. So which means if we devise g of x with f of x, the final answer will definitely be 1 plus minus 2x minus 2 all over x squared plus 2x plus 1. Okay, so you can obviously take out a common factor of a negative, and then you can just say 1 minus into 2x plus 2 over whatever that is here. So this is how it goes, guys. This is how it goes. This is just how it is. Okay, thank you. So yeah, don't forget to like, to hit the follow button, and also have a YouTube channel. So we'll be much very appreciative if you supported us and help us build our channels. Yeah, so yeah, that is how it is, guys. Thank you very much.